Welcome to 4C, which is identifying the number and types of roots for any given quadratic. So let's get started with the first example here. So we got to figure out what type of solutions we have. To do this, we need to have a graph, or this is the way I'm going to do it here. There's a way to do it by looking at the quadratic formula, but we're going to do it by graphing. So we got to look at, first to graph, we need to find our vertex of the quadratic. So we got to go negative b, so our a is -1, we got b is +6, and c, we don't actually need it for this problem, but is -13. So we have negative b over 2 times a, and that's going to be -6 over -2, which is 3. So our x value of the vertex is 3. What we're going to do is we're going to substitute 3 into the equation and simplify. So we have 3 squared is 9, -9, 6 times 3 is 18, minus 13, so that's 9, minus 13 is -4. So our vertex is at 3, -4. I'm then going to go by ones, 2, 1, 4, 5, because we look at a. If a has a denominator, we would go by that, but there isn't. I guess there is 1, so we're going to go by ones. Now I can either do 2 and 1 substitute in, or 4 and 5. I'm going to choose 2 and 1. So let's do that one. So we have f of 2. So substituting 2 in, we're going to find out what the x value or the y value is. 6 times 2 minus 13. So that's going to be -4 plus 12 minus 13 is -5. So that means if 2 is 1 away from the vertex 3, the x value, 4 is also 1 away, so that's going to also be -5. Now I'll substitute 1 in. So 1 squared plus 6 times 1 minus 13. So 1 squared is 1, negative, so it's going to be -1 plus 6 minus 13. So that's 5, -8. And since 1 is 2 away from 3, then 5 is also 2 away from 3, so that's also -8. So let's plot these points and see what we have. We have 3, -4. 3 to the right, down 4. We have 2, -5. And 1, -8. We have 4, -5. And 5, -8. So this is what our quadratic looks like. It's upside down. You would know that anyways, because our a is negative. It will always be upside down then, upside down u. Now we're going to look at how many times does the graph here cross the x-axis. Well, we're looking at the x-axis. It doesn't cross it at all. So if it doesn't cross it at all, our answer is 2 complex solutions. So none, doesn't cross at all, and our answer would be 2 complex. Also, okay, complex involves imaginary. So if you said that there are 2 imaginary solutions, I'd be okay with that also. All right, let's look at the second one here. So graphing it, I'm actually going to go right to the Desmos. So you graph them all the same way. I'm going to look at Desmos just for time purposes. And let's look at how many times it crosses the x-axis. Well, it crosses twice. 2 times it crosses the x-axis. Those are real numbers. So this one here crosses, I'm just going to draw a general graph, what it looks like on here. It would look like this. It would cross the x-axis twice, so that's 2 real solutions. You could say distinct, meaning they're different numbers. So this would be it crosses twice, so 2 real distinct solutions. All right, let's look at the next one. Oh yeah, this equals should be a plus here. That should be a plus. We have the next one graphed, and we see that it only hits the x-axis 1 time. Well, every quadratic has 2 solutions. So this one only hits once. So it comes down, touches the x-axis, and goes back up. It only has 1 solution, so it's 1 real solution. But, so when the vertex hits the x-axis, it's going to be 1 real solution, but we're going to count it as double. So it's going to be a double solution or a multiple of 2. Oh. meaning it's twice, because every quadratic has two solutions. Both solutions would just happen to be the exact same number. Alright, hopefully this helps.